Hey y'all. So this is information from 6.2. We started talking about differential equations in 6.1 and learned how to check and see if a given function was a solution to a differential equation. Now we're going to talk about solving them. And basically, this is the key thing. The strategy is to rewrite the equation so that each variable occurs on only one side. And that's called separation of variables. Okay, so we're basically going to move all the x's to one side and all the y's to another. This is only one strategy. So essentially, I think the first thing is to think about alternative forms of y prime. So y prime we know is the same thing as dy dx. And here we're going to solve that equation, dy dx equals 2x over y. And so I think it makes sense that we can multiply both sides by y. So dy dx times y equals 2x, and then all the y's are on the left-hand side, and then we can go ahead and multiply both sides by dx. I'm going to write this side as y dy, and this side as 2x dx. So now you can see all of the x's are on the right, all of the y's are on the left, and now I can go ahead and integrate both sides. And what that means is, this is all stuff I know how to do. 1/2 y squared, I'm going to write plus c1. And on the other side, x squared plus c2. The thing we've talked about before, right, is if you have some unknown constants and you put them together, you still have another unknown constant, right? And so I think it is totally fine to just go ahead and write it like this. And so in the future, we aren't going to add plus c on both sides because we're always going to just end up putting them together, so I'm only going to do plus c on one side. And so certainly we can go ahead and clear out the fraction if I multiply everything by 2. So y squared equals 2x squared, and then if I do some unknown c times 2, right, that's still some unknown. All right. This is a general solution. To that differential equation. Okay. Certainly you can also go ahead and rearrange it. If I wanted to, I could bring this over. This would be another form. Okay. You could solve it for y, but since there's a y squared, you're going to end up with two answers, and I think it doesn't make a lot of sense to do that. Also, I would just want to note that you can check. If you're going to check, though, you're going to have to use implicit differentiation because you have the y squared. So if I'm checking, right, that would be 2y times y prime minus 4x, and the derivative of c would be 0. And so that means 2y y prime equals 4x, and y prime equals 4x over 2y, which is the same thing as y prime equals 2x over y, which is exactly what I started with. So taking that integral, right, you can check by doing the inverse, which is taking the derivative. And so I know that that is correct. Okay. All right, so growth and decay models. In many applications, the rate of change of a variable is proportional to the value of y. So the rate of change of a variable y is proportional to the value of y. Literally, if I do that, the rate of change, this is the dy dx, is my equals. And this proportional to y idea we've talked about before, so it's some constant times y. It tells us the general solution of this differential equation in this theorem, but I want to show you why that is the case. And again, it is using separation of variables. So if I have dy dx equals k times y, right, I can go ahead and separate my variables. That's going to be my strategy. Okay, so I can divide both sides by y, or write 1 over y dy equals k times dx. So I did kind of two changes at once. Oh, I guess they're doing t's. Sorry, I'll change those real quick. This is with respect to t instead of x, same thing, right? Same idea. All right, now if I go ahead and do the integration, okay, I'm going to get natural log of y equals kt plus c. And the reason that is kt is this is some constant k, and so if I'm doing with a integral in terms of t, if I think about taking the derivative of kt, I get back to k. All right. Now, if I'm trying to get to the y, right? The way that I can undo natural log is by doing e to the on both sides, all right? And e to the natural log of y is just going to be y. And over here, I have e to the kt plus c, which is the same thing as e to the kt times e to the c. If you think about it, how do you add exponents? That was when you're multiplying like bases. Okay, and the idea here is that e to the c means e to just some constant. And so this is actually still an unknown constant. But we want to make sure that we don't confuse it with our original c, and so I'm going to call that a. And so I get y equals a times e to the kt. All right, so again, a is just some unknown constant, right? This is the exponential growth equation. It is the general solution to that proportionality differential equation.